All right. Okay, so this is the mock paper solving of Science Academy um, AS level chemistry first mock for the session 2020. So we begin with paper 1. Okay, so the first question was the values below shows the third to eighth ionization energy of an element. Third to eighth. I think there was a mistake in the question. It stated third to fifth, but it should be third to eighth. So whatever it is, the first ionization energy, as shown here, the 578, is the actually the third ionization energy. So the third one was 578, then 1817, then 2744, then 11577. So after 2744 there is a big jump, 11577. So the 578, I guess you can say. Okay, so 1817, then 2744, then 11577. Okay, we don't need to carry it anymore. So this is third, this is fourth, this is fifth, this is sixth. So there is a big jump between the fifth and the sixth ionization energy. So in the outermost shell of the atom there must be 5 electrons, since these 5 ionization energies are quite close. So look at option C. Option C has 3s2 3p3. This means there are 5 electrons in the outermost shell. So the answer would be C. Question number 2. Which is not the correct arrangement of electrons? Okay, so in all cases the 2s shell has got 2 electrons. Now, so the problem lies with the p subshell, the 2px, 2py and 2pz. You know that the rule is when you are filling the orbitals of a subshell, you first need to put the single electrons in all shells, all orbitals, then if required then pair them up. So in the first option the 2p is filled like this. If this is okay, px, py, pz. So there are 4 electrons in the p subshell. So 1 2 3 4. Okay, so this is all right. In the second p subshell there are 1 2 3 4 5 electrons. So it should have been filled like 1 2 3 4 5. So I think this is okay, all right. In the third option the p subshell has got 3 electrons, so it should be filled like 1 2 3, but the option is stated like 1 2 3, which is not actually correct. So for question number 2, option C is not correct. So C is the answer for this question. Okay, now we move to question number 3. Question number 3. The place in an atom which is occupied by 1 or 2 electrons. Occupied by 1 or 2 electrons is known as for sure or orbitals. Answer is A, because you know electrons are always placed in orbitals. Okay, now which property of an atom does not affect its first ionization energy? You know that first ionization energy is affected by the distance of the outer electron from the nucleus, and the nuclear charge, then the shielding effect, and the kinetic energy of electron. So distance affects, that means the atomic radius would affect, and the number of electron shells, that would surely affect the shielding effect. That is surely proportional to the shielding effect. The number of protons, which is linear to the nuclear charge, and the number of neutrons, which neutrons and neutrals. So the number of neutrons or the presence of neutrons, no way affects the ionization energy, because neutrons have no charge, or it doesn't attract the electron or anything, or doesn't apply any force on the electrons. So for 4, option B, the number of neutrons. Okay. Which of the elements shown below has any two of the following properties? Question number 5. What are the properties? S orbital in the outermost shell, which is the largest. That means in its it must have an S orbital in the outermost shell, which is the largest. That really occurs. The lowest ionization energy among all. Okay, so for sure you pay attention for this. So calcium is in beryllium period 2, magnesium, calcium period 2, period 3, period 4. So calcium has got 4 shells. Okay, and okay, so the atom should contain only S orbital. So calcium might be an option. Krypton is filtered out because krypton doesn't have an S orbital. It has an S orbital, but along S orbitals it also has got P orbitals. Okay, copper has got S orbitals in the outermost shell, the 4s2 or 4s1, whatever you say. Cesium is a group 1 element, so it has got S orbital in the outermost shell, the S1, isn't it? And the position, so we are filtering out krypton and copper. So okay, so we are filtering out krypton. So the outermost shell of calcium is like 4s2, the outermost shell of copper is like 4s1, but cesium, lithium, sodium, potassium, rubidium, cesium. So 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. So cesium is in period 6. So its outermost shell has got 6s1. So this S subshell is the largest, and it has the lowest ionization energy of all because its atomic radius is very large, the shielding effect is high, and the electron also has got a lot of kinetic energy since it is in a 6 subshell. So the answer in this case is D. Okay. Question number 6. For element sulfur, which pair of ionization energy has the largest difference between them? Okay, sulfur, largest difference. So sulfur has got 2, then 8, then 6. So first and second ionization energy, then there will be a large gap. Then 10th, sorry. So first to 6th ionization energy, there will be a large gap. Then 6 plus 8, 14. Then 14th to 15th ionization energy, there will be another large gap. Okay, so the large gap will be between 6 to 1st to 6th, and then 6 to 7th. From here to here, 7 to 14th ionization energy is present here, isn't it? So between the first 6, the 6 to 7, there will be large gap because you are changing the shell. So the answer is, for number 6, answer is D. Okay. The first 7 ionization energies of 3 consecutive elements are shown: 677, 798, and 132. So it's like 677, 798, and suddenly there is a large change. It's 132. The large fall always indicates a change of period. Remember, change of period. Okay, so 7A is got sodium, magnesium, aluminum. They're all in the same period. Sulfur, chlorine, argon, they're also in the same period. Copper, silver, and gold, they are placed in the period to be like this: copper, then silver, then gold. It's like they're going down the group, so their ionization energy should decrease to a large extent. It should get decrease, then decrease, but it's like 677, 798, then 132. First increase, then decrease, huge. then we have bromine, krypton, and rubidium. Okay, so it's like group 7, group 8, bromine, krypton, and then rubidium starts in the next period. So the ionization energy should fall. From bromine to krypton it should increase because they're in the same period, and from krypton to rubidium it should decrease. So the answer in case of question number 7 is D. Okay. Now let's move to question number 8. Oh, my right is very close. Paper will clear very soon. Acha. In which species are the number of electrons and neutrons equal? So beryllium 9 and 4, then fluorine 19 and 9, then sodium plus 23 and 11, oxygen 2 minus 16 and 6. So it asked about electrons and neutrons. So here we have 5 neutrons, here we have 10, here we have 12 neutrons, and here we have 10. Okay, number of electrons here is 4, number of electrons here is 9, so they're not equal. Number of electrons here is 10, number of electrons here is is it 10? I guess so. Is that only fluorine or fluorine minus? Oh, it's 8. Okay, so there are 8 neutrons, and no, oh yes, there are 8 neutrons, and there are 10. Am I wrong? Okay, 18. So there are 10 neutrons, and 8 plus 2, 10. There are 10 electrons. So here number of neutrons and electrons are equal, so 8 has the answer D. What is the electronic question number 9? What is the electronic configuration of an element with second ionization energy higher than each of the neighbors in the periodic table? So first one said about 1s2, 2s2, 2p6, 3s2. Okay, the second ionization energy is very high. So it's like you might guess in this way that since the second ionization energy is high, so there must be one electron in the outermost shell. So when this one electron is removed, to remove a second electron, that means the second ionization energy, you have to go to the next shell. So in the outermost shell there is only one electron, so the element is group 1 element. So the element is in group 1 element, or you may think like that you are not going to the next shell, and if you go to the next subshell the same thing happens. Like here you are removing the 2 electrons from the S subshell, so these energies would be close. But 1s2, 2s2, 2p6, then 3s2, 3p1. So when you're removing this electron, then to remove the next electron you have to move to the next subshell, not actually the next shell, the next subshell. So there will be a slight, quite very small jump, not that much big jump, because big jump means you're changing the shell, but there will be a small jump. That means the second ionization energy in this case will be higher than any of the cases. So for number 9 the answer should be B. Now number 10. Which of the following statement about subshells and orbitals are not correct? Not correct. Okay, A subshell have spherical shapes, that is true. Electrons enter 5d subshell before the 6s subshell, isn't it? 5d. Okay, so S, P, D, F, 0, 1, 2, 3. So 5d means 5d, d is 2, so 5 plus 2 means 7. And 6s means 6 plus 0, that means 6. Okay, so electrons should enter 6s subshell first. but it said 5d subshell before 6s subshell. That is not true. Okay, so B is not true. If subshell can accommodate 6 electrons, yes, that is true, because F subshell can accommodate a highest of like 14 electrons, but here they said 6. So if they can give place to 14 electrons, they can for sure give have a place for 6 electrons. P subshell can accommodate 6 electrons. That is also true. So 10. B is not correct, so B is the answer. How many electrons are there? Question number 11 in hydrogen carbonate ions. HCO3 minus. So hydrogen has got 1 electron, carbon has got 6 electrons, and each oxygen has got 8 electrons. So 8 3s 24. So 24 plus 6 30 plus 1 31, and extra electron from outside, so it should be 32. The answer is C. Okay. Number 12. Positron is another discovered particle in nuclear reactions. It actually means positive electrons. What might be the deflection property of positron and electron? So this question has actually got 2 answers. Positron and electrons, since electrons are very light particles, so positron should also be a very light particle, and it's like so they would bend more, so they have got charges, so they should bend. So 12A, option A say that option A actually they are showing that it's not bending, so option A is filtered out. Option B, C, and T. Now option B is in comparison, option B is less accurate because it's bending less, whereas C and D are bending more. So positron and electron, so 2 things, positron is positive charge and electron is negative charge. So electron should bend towards the positive charge plate upward, which is C, and positron should bend towards the negative charge plate downwards, which is D. So if you give either C or either D as the answer, or both C and D as the answer, both will be correct. So C, D, or both. Sorry about that, but you have to face these types of MCQs again and again. না হবেই বলছি না, হতেও তো পারে। আচ্ছা, so that's not the case. We have a big game later on. Which ion has the same electronic configuration as Cl minus? So Cl minus has got the configuration of 2 8 if I'm not, okay, 288. So F minus for sure it is not, because it's 2 8. Then P plus, no way, because P is 285, so P plus is 284. Scandium 3 plus, okay, so 3 plus, and silicon 4 plus. Silicon is 284, so each 4 plus means 28. So fluoride is not matching, phosphorus is not matching, silicon is not matching, so the answer should be scandium 3 plus. You should memorize the first 20 elements of the periodic table. That is important, because in the exam time, if you keep on looking again and again the periodic table for these common elements, then you're losing your time. So that's why the first exam I didn't give a periodic table, and I won't also give it later. From the data booklet, I will take the periodic table off. Okay. Each of the options below shows the first 3 ionization energies of 2 elements in each option. Which of the options shows the ionization energies of 2 elements in adjacent groups? Question number 14. Adjacent groups, that means adjacent groups, so if one is group 1, then another will be group 2. So option A said like, so option A said like 231 and 3200 and 4670. So here is a big jump, so this must be a change. So there is one electron in the outer shell, so it's group 1. Now secondly, it said like 5670, then 17,000. Okay, so here is another big jump. So one electron in the outermost shell again. So these are the this atom has also got one electron in the outermost shell, this one also, so they're in the same group, not they're in adjacent groups. So option A is filtered out. Bad 884. Option B. Then 4678. Okay, so here's a big jump, so there must be a change in shell. So in outermost shell there is one electron. Now okay, so 9765 and 10234, they are quite close. Then there is 32189, so it's a big change. So in the outermost shell there is 1, there is 2, there are 2 electrons. That means this in group 2, this in group 1. That means these 2 elements are in the adjacent groups, so it's group 1 and this is in group 2. So option B would be the answer. Okay. Now, which of the following statement about P3 minus is correct? Okay. So phosphorus 3 minus, it has an atomic mass of 31, atomic number 15. Then chlorine, then 35 and 17. It's minus. Okay. They are isoelectronic, isn't it? I'm not sure. So 15 is gaining 3 electrons, so there are 18 electrons. 17, it's gaining 1 electron, so it's also 18. So yeah, okay, they're isoelectronic. Point number 2, they're isotonic. Isotonic means same number of neutrons. Let me see. Here are 16 neutrons, if I'm not wrong. Okay. And here are also 17, 34, and 18. Okay, 18 neutrons. And here it is, there are 16 neutrons. So they are not equal, isn't it? So they are not isotonic. So what, 2 is incorrect. And if 2 is incorrect, then option D, I mean 1 must be correct. Okay, so answer would be D, because if 2 is incorrect, then it's no need to check question number option number 3, because there are no options like 1 and 3 only. So therefore 15, the answer is D, number 1 only. Okay, number 16. Which of the following might be okay, big game, birat khela. That means there is something uncertain. A student said that 2 elements might be different by judging their chemical symbols. Okay, if chemical symbols are different, then they must be different. Okay, so this is correct. Student said that 2 elements might have the same number of protons when their symbols are not given. No, if the symbols are not given, then their proton numbers may be same, because symbols are not given. You never know that whether the symbols will be same or different. So this is a big game, because here you are not sure, but in option 1 you are sure. Okay, and student said that I'm not telling that these 2 same charge spaces have the same number of electrons, but they might be isoelectronic. Okay, this is also a big game, because the student said they might be isoelectronic. That means yes, the student is not sure about it. So this is also a big game. Okay, so 2 and 3 are big game. That means the answer is C. Okay, so, we don't need to check all, because if 1 is wrong, then 2 and 3 must be correct. Okay, 17. X is a particle with 18 electrons and 20 neutrons. 18 electrons and 20 neutrons. Okay, 20 neutrons. So in argon it is 38 18. Calcium it is 40 20. Okay, 2 plus. In potassium it is 39 and 19 is plus. So how many neutrons? 20. How many neutrons? 20. How many neutrons? 20. So all of them has got 20 neutrons. Now it's time to check about 18 electrons. So argon has 18 for sure, calcium has 18 for sure, potassium has 18 for sure, because calcium has had 20 electrons, so it has lost 2, so 18 remains. Same here. So all of them are correct, so answer is A. Okay, now number 18. Compound X is made up of 2 elements. One element has the second highest value of the first ionization energy in its group. Second highest value of the first ionization energy. Okay, so in this case potassium is this group, which compound could be X, and the other element has the highest value of first ionization energy in its group. Which compound could be X? Actually, if we consider the second information, then none of these are correct, but that shouldn't be. So let's focus on the first. Calcium is beryllium, magnesium, calcium, third element in the group, and chlorine is fluorine. Chlorine is the second element in the group, so its ionization energy is the second highest, and fluorine being the first. Magnesium bromide is beryllium, magnesium, so its ionization energy comes after beryllium. Beryllium has the highest ionization energy in the group, and magnesium is the second highest. In the third case, there is sulfur, which has got the second highest ionization energy value in the group, because after oxygen comes the sulfur, so oxygen is the second element, so it must have a second highest value of the first ionization energy in the group, because you know down the group the ionization energy decreases. So all of these are the answers, so 18 must be A. Number 19. Which graph represents the number of unpaired electrons for an atom with proton number 13 to 18? Unpaired p orbital. Okay, so I would consider only the last subshell of the p last orbitals, last subshells p orbital. So what about 13? 13 is 2 8 3, so 3 third shell, so it's 3s2 3p1. Now about 14. 14 is 2 8 4, so it's 3s2 3p2. Now 15, it's 2 8 5, so 3s2 3p3. Okay, so 1 1 2 1 2 3. Then so it's 15, right? Okay, so 16 2 8 6, so 6, so 3s2 3p4. Oh my god, look at my 4. 1 2 3 4. So here there is one unpaired electron, here there are 2, here there are 3, but here there are 2. So the number of unpaired electrons are increasing from here to here, and then has started to decrease. So only one is correct. Since one is correct, then 2 3 there is no need to check, because we have found the information from the electronic configuration, which is for sure. So we don't need to check option 2 and option 3. So only one is correct. So 19 has got the answer D. Okay, so the last one, isn't it? Which two outer electronic configuration has the lower ionization energies than one of them? That means except one of them, the other two must have the lower ionization energy. So 3s2 3p6. Then we have 3s2 3p6 3d2, then 4s2 4p6. So two ionization energy must be present which is lower than one of them. So look, here it ended at 3p6, here at 3d2, here at 4p6. So this one has the lowest ionization energy, since this configuration ended at D, and this configuration ended in the next shell. So these two have got ionization energies which is lower than this one. So 2 and 3 is correct. So the answer should be C. Okay, that's all for the solving of paper 1. Thank you.